When I was a kid, I wanted to know everything. I kept asking things like, why does the moon rotate around the Earth? Again and again I asked, why? So imagine how disappointed I was when I learned something astonishing. I had been asking the wrong questions all my life long. You probably know the story of Newton sitting under the apple tree and wondering, why does the apple fall to the ground? I have bad news for you. We can never know why. But here's the good news. Instead of finding out why the apple is falling down, Newton found out how the apple is falling down. He found out that we can calculate the path and the speed of a falling apple using mathematics. The question I should have asked all along was how, and not why. I don't know why the apple is falling down, but I know how nature works. So this is great news. Instead of philosophizing why gravity exists, we can calculate the speed of a falling apple. Is it going to fall on your head? Do you have time to drink a coffee before it hits you? Once we have a working model of nature, we do experiments. We calculate what we expect to happen. The science of physics is about modeling nature with mathematics, and not about wondering about the why for its laws. But sometimes we get surprised, puzzled, because some new experiments cannot be explained with our current theory. For example, we are really excellent in describing falling apples. But what happens if we shrink the apple? If the apple becomes the size of an atom, Newton's law becomes useless. And of course physicists are wondering, why are the laws of physics different for tiny objects? Nobody knows. But physicists discovered quantum mechanics and how tiny objects interact. And without knowing why, this discovery led to the development of laser, GPS, computers. It shaped our modern world enormously. Let's shrink the apple even further. Let's make it 1,000 billion times smaller than an atom. We cannot do experiments on such tiny length scales with our current technology, but we have no reason to believe that the laws of physics we use today to model an atom will still work to model these incredibly exciting new sizes. Asking why is the very human question that drives our vision of understanding nature, but the answers we can find are always only a temporary model of the how. So physics is like a Russian doll. With every new law of physics we discover, we open another figurine. Why does physics look like this? I don't know, I have no idea. But I can ask a much more exciting and useful question. What will the next doll be? And how is it going to work?